So this is session 7. Session 7 is about control structures. This is a real programming part. Technically, what we have done so far is the prerequisite for programming, that the language, basic building blocks of a language. Any language have some characters, some words, some data types. This is what any language is made up of. Now we have learned that, we have learned sequence, we have learned data types, how the data is handled, variables, objects, mutable, immutable, the keywords. We learn how to write Python program, but we have not learned how to do real programming, and that comes when you learn the control structures. Let me show you my first program on control structures. This is a simple program which uses a control structure, that is if statement. Take a closer look at the program. I am taking a variable and assigning a value 100. So variable 1, var1 object, immutable object, I am assigning a value 100 to it. So far so good, but this is the control structure if statement. If var1. So this is expression. This is treated as a true or false. This should be either true or false. This should be results into evaluated to either true or false. So any non-zero value in Python is treated as false. 0 is treated as true. Let's see that. So if var1, and this is a colon, this is the syntax. After expression you have to write this, and then print. That means if this is true, if the results into true, then we got a true expression value, and print var1. If var2 equal to 0, we are talking about this time I am assigning another variable, another object with value 0 to it, and I am checking the value var2. If it is 2, we got a true expression, print value 2. Let's see which one is executed, 1 or 2. That will actually give us, irrespective of what I told you, whether I was right or wrong. The statement will tell you, because it is simply put, this statement is executed when var2 is equal to 0, and whether it is taken as true or not. So if it is true, this will be executed. If not, it will not be executed. Similarly, var1 is 100. If it is considered true in Python, this will be executed, else it will not be executed. In fact, both these statements, first the expression and then the value. Similarly, first this sentence and then the value, because this is printing the value, and this will be executed in both cases. Point to be noted, same, indentation is mandatory, and they should be indented at the same number of spaces or tabs. There cannot be, the statements cannot be one space extra here and there. I mean, this is, if I do this, this is wrong, not allowed in Python. This is not allowed. This should be at the same level, and this should not be, this is also not allowed. This is also wrong. So whatever you want to put along with the, for the condition, you have to put them at the same level, because indentation is mandatory in Python for understanding, making readable, and for the block. We call it a code suite. Now let's execute it. Python 3 python1.py. Let's see what happens. So what is treated as true? Non-zero value. I was wrong when I said 0 is treated as true, because 0 value, the var2 value, that expression is not executed. var2 was 0, and when 0, that execute, that statement, that conditional expression was not executed at all, because the var1, the first line is, I can see first line and the value of var1. I don't see var2 here. Therefore, we can safely say that Python treat non-zero value as true. Non-zero value is treated as true and 0 is treated as false. Unlike shell, shell is the other way around. In shell, where 0 is treated as true, any non-zero is treated as false. That is interesting observation. In shell programming, 0 is considered as true and any non-zero value is considered as false. In Python, any non-zero value is considered as true and 0 is considered as false. Let's look at another program. In C language, 0 is false. In Python, 0 is false. So probably it is coming from C language, because C language treats 0 as false. So this is another program. Let's look at this program. This program is slightly better than this. Variable var1 is assigned the value 100. If var1, we got a true expression, so this will be executed. But what we are doing, we are using another construct here. If not, else, print, we got a false expression value. So this is, if this condition is false, then execute this statement. So we got a complete if construct, if, else. Unlike shell, there is no closure. In shell, we have fi. In C language, we have closing curly braces. So we don't have any closure here. So if var1, execute this. If not, then this. This is one first example. Second example is var2 is 0. If var2, if it is true, execute this. Else, execute this. So this way, what you can expect is, in first case, you can expect this output. In second case, you can expect this output, var2, because var2 is 0. So you can expect this. It is false, and print var2. It will display the value as well. So we can expect this output and this output here. And finally, this statement will be executed in both cases. Let's try. Yes. So 1, we got true expression value, which is 100. Second, we got false expression value, which is 0. That means else statement is executed. So if true, then this, else this. So when we execute this program, Python 3, Python 2.py, so this statement, this block, if value var1 100, if var1, then print this, else print this statement. So because 100 is non-zero value, so in this case we will get this output, which is happening here. In second example, var2 is 0. Since this is treated as false expression, so else part will be executed, which is this. So therefore this is what we are getting here, plus the value of var2, which is 0. And goodbye will be executed in both cases because it is out of the block. Let's look at the third program. This program is slightly different. We are getting multiple conditions. Var is 100. If var equal to 200, this is again, as I said, expression. So this is the equality expression, comparison operators. So that's what we discussed, operators, when we discussed all the operators. So if var equal to 200, we'll get this, which is not true. So this will be ignored. This statement will never be executed. Else if, this is else if part of if statement, if construct in Python. Elif, E-L-I-F, if var equal to 150, which is also not true. So this will also be ignored. Elif var equal to 100, this is true. So this statement will be executed. Else 4, this will not be executed. So in this, when I try to execute this program, this block will be executed. So in this case, we are checking with multiple values. If 200, if 150, if 100, if 400, if nothing, then do this. That is else part. And finally, you'll get goodbye. So let's try Python 3. Yes, that's what I told you. Else if, because value is 100, so it is compare var equal to 100. And we got the value 100 printed and this statement executed. So this is an example of if, else, if, else, if, else, if, and finally else. How beautiful, how readable Python programs are because of this indentation, because of alignment, and which is mandatory. That gives you complete understanding that okay, which part will be executed up to where. Let's look at the fourth program. This is example of another example where 1 is 100 if where 1 is less than 200. Again we are comparing, yes it is less than 200, so therefore this will be executed. Value of expression is less than 200. And now here I am putting another nested code block. We call it as nested if within if. This is nested block. We are checking the value if where 1 is equal to 100, which is 100. No, this will not be executed. Else if 100, which is 100, yes, this will be executed. And this will be ignored. If where 1 is less than 50, this will be ignored because it's not that. And could not be a true expression. This is never be executed because it is already found. So it means how do we execute expressions, how do we execute statements based on a condition, and how can we put one condition within another. Like this is it less than 100? If yes, then continue this block of if statements. If not, then continue this block of statements. So let's execute this. Python 4. Expression of value, where expression value is less than 200, this is executed, which is 100, and this is executed. Look at another program, program number 5. This is single line code block, single statement. If where 1 equal to 100, then print value of expression is 100. That means single line. So this statement will be anyway executed, and this will also be executed if it is 100. Which is true in this case. So we got this value. So what we have discussed, 5 programs I demonstrated. There are total 16 programs. We will discuss rest of the program through the presentation, which will have the code also and output also. Session 7, decision making and loops in Python. What we saw quickly is the demo on decision making, that is if construct. So in this session we'll understand decision making and loops, both parts. Decision making structures, that is if and nested if statements, single statement switch, and loops in Python. I give demonstration up to here, single statement switch. Let's look at. This is how if statement works. Your program flow is continuing one by one. We encounter a problem, a condition. If the condition is true, you execute one sequence of code, one set of statements, one suite, and if it is false, then you ignore this and you continue with rest of the flow of the program. So this part is executed only if the condition is true. That was first example we discussed. And then we continue. The goodbye statement was appearing here. Goodbye was executed in both cases. So when the condition is false, it will take you out of this body, this part, ignoring this part and coming out of the program. So you can treat this flowchart a good understanding how actually it is working. We can take a decision if you have done some condition as input or one or more alternatives. With one or more alternatives. For example, I shall go for a walk if the weather is good. Now this is the condition, if the weather is good. This statement can be either true or false. George Boole published a book on this algebra of logics and thoughts, and according to him, no statement in this world can be both true and false together. It will be either true or false. So this entire statement will be either true or false. It cannot be true and false both, because either weather can be true or weather can be bad. So I shall go for a walk if the weather is true, weather is good. So decision making structures require that the programmer specify one or more conditions to be evaluated or tested by the program along with the statement or statements to be executed if the condition is determined to be true. Optionally, other statements to be executed if the condition is determined to be false. That is part of the else statement. So these are the possible examples. Python assumes any non-zero value and non-null value as true, and if it is either 0 or null, then it is assumed to be false value in Python. So we have if statement, if else statement, and nested if statements. We have seen examples of all. If statement consists of a Boolean expression followed by one or more statements. An if statement is followed by optional else statement, which execute when the Boolean expression is false. And nested if statements, one or more, one if or else if statements inside another if or else if statements. Now this is the if statement. First, if statement contains a logical expression using which data is compared and a decision is made based on the result of the comparison, and it goes like this: if followed by expression, and if it is true, then statements are executed. It goes like this: you check a condition, if condition is true, then it will execute that piece of code, otherwise it will continue the false part of it. This is the first program I demonstrated. Python 3, variable 100 value. If var 1, we got a true expression, which is true in our case. This will never be executed because 0 is treated as false. So this will not be executed, and this was the output demonstrated to you. If else statement. An else statement can be combined with an if statement. Now here, if statement starting here, ending here. So we are putting true part of the code and false part of the code. That is else part of the code. So if the condition is true, we put some set of statements. If condition is false, we put another set of statements. And we close if here, and then whatever is outside the body, that will be continued. This is if else example. An else statement contains the block of code that executes the if condition expression resolved to 0 or false value. The else statement is an optional statement, and there could be at most only one else statement only following the if statement. The syntax is this: if expression statements, else expression statements. Point to be noted is if and else, they are at the same level because they are forming the statement. And statements, all the statements are going at the same level, same indentation level, because they are forming the block of the code which is to be executed. Indentation is very, very important in Python. This is if else statements example. I demonstrated this also. Var 100, if var 1, execute this, else execute this. In our case, this is not executed. Var 2 is 0. If var 2, which is false, so this will never be executed. This is not true, so therefore this will not be executed because var 2 is false. It is 0. 0 is treated as false. So print, we got a false expression. So we got true, that is 100, and false, that is 0. We got this output, and this statement is executed in both cases because this is out of the if statement block. Point to be noted: this if else are exactly at the same level. There should be no indentation, there should be no here and there, and all these print statements are coming at the same level. That is Python mandatory syntax. The else if statement. There are situations when you want to execute multiple conditional expressions. The else if statement helps you for that. The elif, that is ELIF statement, allows you to check multiple expressions for the truth value and execute a block of code as soon as one of the condition evaluates to true. So expression, if expression is true, else if another expression, another expression, and you continue. If all your expressions are exhausted, finally, if nothing is true, everything is fails, then you can use another else statement here. If elif, you can continue writing all else if statements. I am giving here if marks are less than 35, else if marks are less than 45, else if marks are less than 65, else. So which one will be executed? If marks are less than 35, less than 45, less than 65. So this will be executed or no? No. Because your marks are 75, assuming that your marks are 75. So this will not be executed. This will be executed if less than 45, so this will be not be executed. Less than 65, so this will not be executed. Only this will be executed, because none of the three conditions are true. If your marks are 50, then what? What will happen? So will it be executed? This is false, so this will not be executed. Less than 45, no, this will not be executed. Less than 65, yes, this will be executed. So we say if this condition is true, never say which this condition is false. Core Python does not provide a switch or case statements as in other languages, but we can use if else if statements to simulate switch case. In latest version, we need to check whether it is available or not. Earlier version never provided this, so this needs to be a question. We need to check the latest documentation whether they are available or not in Python. So this is not a final statement that they are available or not, but yes, we can verify whether switch or case construct available in Python or not. Earlier they were not there. Python 3, next program. So this is the same example, else if statement example. We are taking value 100. If it is 200, execute this, so which is not true. If it is 150, execute this, so which is not true. If it is 100, execute this, this will be executed. And finally this will be executed. So we got this third block. Nested if statement, if within if. In a nested if construct, you can have if else construct inside another if else if construct. If expression, then statements, and then you start another condition. It's something like if I ask you, are you a resident of the world? You will say, yes, I'm not from any other world, I'm from the same world. Are you a resident of Asia continent? No. Are you a resident of New Delhi? No. So this is one if, another if. If I ask you, okay, are you a resident of world? Yes. Are you a resident of USA? Yes. Are you a resident of Philadelphia? I can't pronounce it, sorry. Philadelphia. Is it correct? Oh, good. Okay, let me use better name. New York. So are you a resident of New York? So this is called nested if statement. And this is, so point to be noted is again the indentation which makes it beautiful readable program. Statements. If this expression and all this else if and else if are at the same level. Point to be noted. And this expression, this if statement is clearly that this is one statement, if statement, and this is continuing here, else if else, because they are at the same level. So this if statement is continued here, this is continued here, and whatever this inside, that is another set of, this is called nested if statement. And this is the same example now, example number 4, where 100, if less than 200, which is true, this will be executed, so the control will get inside this block. Now inside this block we are testing multiple conditions. Is it 150? No. Is it 100? Yes. Is it 50? No. So this will be executed. So two statements are executed based on two conditions are checking. We call it as narrowing down your conditions, narrowing down your search. First we narrow down, is it less than 200? Yes. Is it equal to 100? Yes. You can create a very good puzzle here, you can and you can create very good examples and games here. Guess a number. and then write multiple if statements to narrow down the search by the player. Like guess a number between 0 and 500, and then start checking, is your number less than 500? Greater than 200? Yes. So you execute one set of statements. If no, then another set of statements. Then make another guess. Is it less than, let's say, 400? That will make you narrow down, and then you can actually make a very good game out of this kind of guessing work. This is this nested if statement example. So let the user guess the right number. If it is greater than 200, less than 200, this entire block will be executed. If not, this will be executed. Single statement switch, where you write single statement. So we write this if expression, and then we write the single statement. This is a single statement. Sometimes we need a single statement only. The loops construct. Loop is repetition. You execute some set of repetition code, but then there must be some kind of termination mechanism inside the loop. For example, you want to create a body of statements here, 5 statements, and you want to execute these 5 statements based on a condition. You are checking the condition here. As long as the condition is true, you want to execute the same statement, or you put conditional code here. So you check the condition. If the condition is true, then you execute this. If the condition is false, you don't execute the code, but you continue repeating as long as the condition is true. Let me give you an example. Ask a number from the user. User says 10. Display the value 10. Ask another number. So every time you continue asking. But if you don't ask the question, do you want to continue? Then this program will be infinite, because this will never terminate. So when you are repeating same piece of code, enter a number, enter a number, enter a number, it will continue executing. So you have to put another statement, another way to to terminate the loop. So we have these loops here: while loop, for loop. The while loop repeats a statement or group of statements while a given condition is true. It tests the condition before executing the body. For loop executes a sequence of statements multiple times and abbreviates the code that manages the loop variable. Meaning we are giving the condition inside the syntax, inside that for loop itself, that okay, from where to where. Let me give you a simple example of this. While loop, while the condition is true, while I allow you to continue walking. So you continue taking steps. When you are done, I will say stop. For loop, start counting and count only 5 steps. Move 5 steps. So I am giving you starting, I am giving you where to stop. So for loop have a starting condition, termination conditions, and every time you have to jump 2 steps, not single step. So that is step also can be given. We will understand with examples. And nested if is nested loop is loop within loop, like matrix. In matrix, how we do? We count like a matrix consists of 3 rows. So we'll write an outer loop here for 1, 2, 3. 0, 1, 1, 2 and 3. But for every loop we need to count a value, columns also. Suppose there are 5 columns. So 1, 2, 3, 4, 5. Then this loop is complete. The 5 columns are complete. Then we count another row, second row. Now we count another loop, 1, 2, 5. Then we count the outer loop, 3. So this loop is going outer, this is outer loop, and this is inner loop. For every value of outer loop, it is executing 5 times. This is called loop within loop or nested loop. We'll look at some examples to make the concept clear, and that will help you. The first is while loop. A while loop statement repeatedly executes a target statement as long as the given condition is true. The moment given condition becomes false, this will stop. So here these statements may be single statement or block of statements. And this condition may be any expression which results into true. And we know the definition of true and false now. When the condition becomes false, the program block exits. Program control passes to the line immediately following the loop. All the statements indented by the same number of character spaces after the programming construct are considered to be a part of a single block of code. Python uses indentation as its method of grouping statements, and this is what I have been trying to explain. So this is loop diagram, for loop example. So this is given in program number 6, Python 6. While expression statements, you check the condition. If it is true, you execute a code block and you continue executing. You don't proceed with the main logic, main flow. You continue, check the condition again. If the condition is condition is true, continue executing the code. But then you must put something here to change the condition. If no statement is put inside this block to change the condition will always remain true. And the loop will become infinite loop, and there will be no way to come out except the control C. If the condition is false, this block will not be executed. Simple. This is repetition. Now this example makes the concept simple. Count equal to 0. So this is initial condition, count equal to 0. While count less than 9. So I know the count is less than 0, so therefore it will get inside the loop because count is 0. So it is less than 9. So it will go inside the loop. Print the count is and the value of count, which is 0 right now. So it will print 0. Now I am incrementing the count. Count is equal to count plus 1. So after this statement is executed, count will become 1. While count is less than, so this is the again repetition. This is what I put here, repetition, repeat this. So while count less than 9, is it less than 9? Yeah, it is still less than 9, it is 1 only. So print count is, now this is value is 1, so print value 1. Count equal to count plus 1, so count become 2. Go back to the same program. While count less than 9, is it less than 9? Yes, so count is still 2. So print count. So it will print count 0, 1, 2, 3 till it is less than 8. I mean till equal to 8. The moment it becomes 9, the condition becomes false because it is equal to 9. So therefore this body will not be executed and it will execute the body or the statement immediately following the loop. This is a while loop, and this is what is the output of this loop. 0, 1, 2, 4, 6, 7, 8, 9. This is a very good example of a while loop in Python. The infinite loop is important to understand. They are useful in some cases, not always. Let's understand when they can be useful. A loop becomes infinite if the condition never becomes false. You must be careful when using while loop because the possibility of that condition never resolve to a false statement, a false value. This results in a loop that never ends. Such a loop is called infinite loop. An infinite loop might be useful in client-server programming, where server needs to run continuously so that client program can communicate with it when required. So that is infinite loop. This is example of infinite. Don't try to run this program because in order to terminate you have to use control C here because it will continue asking the number, and this is the example I quoted you. So var equal to 1 while var is equal to 1. This condition construct an infinite loop because I am not changing var anywhere. I am not changing it. So where is change is 1, it will remain 1 because I'm not changing inside the body. Because inside the body, inside the loop, I'm doing it simply asking a number from the user. Input, enter number, user enters some number, you entered, I'm displaying that number. So enter a number, I entered 5, you entered 5, and this two statements are being executed non-stop. Because for me, condition is where equal to 1, and I'm not changing where inside the loop. So this is infinite loop. So how do I come out of loop? I have to press Ctrl C. This is example of infinite loop. You can also have else statement with the loop. While count is less than 5, count equal to 0, count less than 5. While count is less than 5, print count is less than 5. Count equal to count plus 1. Continue executing it. When this condition becomes false, means count becomes 5, then the else part will be executed. So this body will be executed as long as the condition is true. This is loop part, and this is else part of the loop. So that means you will get 0 less than 5, 1 less than 5, 2 less than 5, 3 less than 5, 4 less than 5. But finally, when count becomes 5, this body will be out of this loop and else part will be executed, which is this, and you'll get 5 is not less than 5. So we can have else statement within the loop, with the loop. Single statement, the way we have if statement single, we can also have loop also with a single statement. Like user this flag equal to 1, while flag, print given flag is really true. And this is infinite loop. Why? Because I am not changing the flag anywhere. So remember, it is better not to try this example, same, because it goes into infinite loop. And the reason being, I am not changing flag anywhere inside the body. If I am not changing it, it will remain true, it will remain 1. And you need to press Ctrl C to exit this program. Yes, plus 1, plus 2, whatever. I need to change some condition. Something I need to change. And I need to verify that at this statement this should be false, and this should exit. For loops in Python. I have executed. You can see the output. It is there in your program code. So it will continue printing that non-stop. So you have to press Ctrl C to come out of it. For loop has the ability to iterate over the items of any sequence, such as list of or a string. So here you for good thing about for is you specify iterating where in sequence. So variable name in followed by number of items, and then statements. So you are giving which variable and what value it is going to take. You know everything right in advance. Item from the sequence one by one at a time. Next item from the sequence, execute statements. Then next item from the sequence, execute statements. Next item, continue. If no more items left in the sequence, exit. So this is the best and most obeying loop, which will actually very clean loop, I must say, because this can never go infinite because you are putting everything inside the sequence. What value, what all value it can take. So this has ability to iterate over items of any sequence such as list or a string. For iterating variable, this can be any variable. You can take any name, give it any name in the sequence. If a sequence contains an expression list, it is evaluated first. Then the first item in the sequence is assigned to the iterating variable. This variable, this can be anything. Don't go by the name here. Next, the statement block is executed. Each item in the list is assigned to this variable, and the statement block is executed until the entire sequence is exhausted. Let's understand with example. I'm taking two examples. One is I'm taking a character string, and second I'm taking a list, and we are trying with both. This is given in Python program number 10. For letters in Python. So letter, every character will be taken one by one. Print the current letter is letter. So it will first print P, then Y, then T, then O, then H, then O, then N. First example. Fruits, banana, apple, mango. So for fruit and fruits, the current fruit is fruit. So it will print banana, apple, mango, one by one. Because it's going by one all the elements. So this is a good example that how sequence can be considered, can be used to make a loop with very well, full knowledge of where the loop will start, where the loop will end. Iterating by sequence index, you can also use index. For example, for index in range of length of fruits. When you say length, it will get how many elements are there. There are 3 elements. And you say range, so I want to execute one by one all the elements. And you are using fruits index. So 0, 1, 2. This time we are using index, and we don't ask me what is index, because we have studied that index in the lists. Element number starting with 0. So this time, instead of using the individual variable, we are using index to get inside the list and executing one by one. Same output will remain the same. So this is alternative way of iterating through each item is by index offset in the sequence itself. That we have already done in the if statement. That already we have done in the sequential programs. In the sequence, that's simple. We have done that. Or you can put a if condition here. That is another, if you still want to use that, for example, what you are asking is a very good scenario. The scenario is if the fruit is apple or banana, but there are 100 fruits available here. Only then display them, else do not display them. I mean, go check and every fruit. If the apple is banana or apple is the mango, I mean, only you want to print 2 out of 100 fruits available in the list. In that case, yes, you will continue with this. But then, what you will do? This is what we have learned just now. What? If statement. If the fruit index is equal to, you will compare it and then display it. Else, how to proceed, how to continue the loop. Because you don't have to terminate the loop. You don't want to terminate the loop. You want to continue testing the loop, all the fruits one by one. But you are displaying only when certain fruits are available which you want to search. In that situation, so you have to put a condition, but then there has to be some extra statement which will ignore rest of the statement and continue executing the loop till all the elements of the sequence are exhausted. So this is a very good question you have asked. The answer is coming up shortly. Using else statement with loops. Python supports to have else statement associated with a loop statement that we have discussed in while also. If the else statement is used for a for loop, the else statement is executed when the loop has exhausted all elements of the list. If the else statement is used with a while loop, the else statement is executed when the condition becomes false. That's what we have studied. Example of using else statement with loops. This is else statement with for loop. Be very, very careful, extra careful about indentation. These are 2 for loops here, nested loop actually. So this is first for loop, this is never terminating. This is terminating here, the moment you see some statement at this level. That means this is the final loop, the first and final loop. Inside this loop, we are keeping another loop. Now, this is what you are actually looking for. This is something what you are asking similar to this. For number in range 10 to 20, that means you are iterating from 10 until 20. So you are doing for loop. But for every loop, you are checking for I in a range 2 to number. Means you are counting from 2 to that number. Number means it will be 10, 11, 12, 13 and so on. We'll discuss 4 examples. So first time the num is 10. So for I in a range 2 to number, so this loop will be executed for this 10 value. This will be executed 2 to 10, because we are giving 2 until number is 10. So if number percentage I means 10% I, we have done the expressions, please don't ask, it is remainder operator, so it is 0. If it is equal to 0, if num percent I is 0, j equal to num divided by e. Calculate the second factor. So print percent d equals d multiplied by d. That means you will get the second factor. So like this, 10 equals to 2 multiplied by 5. You are breaking it, you are calculating it. That is 10 divided by 5, 10 divided by 2, which is equal to 5. So you are printing j here. So this is how we are inserting the value. Percent d, the first variable will go here, that is 10, equals percent d, I will go here, 2 multiplied by j is 5, j will go here. So this will be the output, 10 equals 2 multiplied by 5. Break. This is what the statement was you are looking for. Continue. That means break means break this statement, break the loop and move on to the next number. This loop is break now. Break means stopped, interrupted. I don't want to continue. That means this value 2 is checked, 3, 4, 5 will not be checked. Though I given the value here from I is 2 to 10. 3 will never be tested, 4 will never be tested, 5 will never be tested because of this break statement. I am interrupting the loop. This break is interrupt. So that means it will come out of this inner for loop and it will start from here back again. Now I am here 11. So let's look at, because I am going to explain all 4 examples which will make it clear. So 10, 11, 12, 13. This is what I am trying. 10 we verified. Now let's go on to that 11 value 11. So a number is 11. We are here. For I in a range 2 to number, that means from 2 to 11. If num percent I, right now I is 2. So what is 11 percentage 2? Is it equal to 0? No. So if no, then increment it, because we are going one by one. Take it 3. Is if num percent I 0, is 11% 3 equal to 0? No. So therefore this will now never be executed. So continue. I becomes 4. So is 4, 11% 4 equal to 0? No. So this will continue and this condition is never true. If this condition is never true, these statements are never executed. So this loop is executed successfully but never reaching to this condition. So therefore this else part will be executed, which essentially means we are trying this 11 to divide by all the number from 2 to 11. If it is not divisible by any number, then we are displaying this message. 11 is a prime number, and that's why we got this. 11 is a prime number. We are continuing with the 12. I in 12. 12 percentage 2 is 0. Yes. And you will get the number here. Simple. 12 equals to 2 multiplied by 6. We continue with 13. Same situation. 2, 3, 4. Continue dividing. 13 will not be divisible by any number. So therefore 13 is a prime number. So what it is doing, it is displaying the prime numbers, and if this is not prime, it is displaying the factors. This is outer loop. It will go from 10 to 20. So you can take like this: 10, 11, 12, 13 up to 20. This is how you do a dry run. Okay, take one value at a time. Then for I in range 2 to 10, 2 to number is 10. So here another loop is starting, and that loop will go from 2 to 10, right? This is another one loop is starting inside this. For every value there will be a loop starting. You could have given any number here. It is just a range, just an example. It's just an example to give you example of nested loop and break statement. So you could have given any number, you could have asked any number from the user, you could have taken that also. Yeah, okay. You are giving num here because I have something back of the mind. I want to try this number that I just want to verify is it a prime number or not. So what do I do to check the prime number? I divide that number with every number starting 2. You may fine tune it, and the fine tuning would have been a number is never divisible by more than half of this number, right? Like 10 can never be divisible by any number greater than 5. 100 cannot be divisible by any number greater than 50, correct? So this inner loop can be half of it. You can safely do it num divided by 2. You got it? That will be fine tuning of the loop. Obviously you can do that. But we are trying on the safer side. We are just because objective is not that here. Objective is the conditional execution and verifying, making a effective use of this expression. And this is a good program to check all the prime numbers between 10 to 20. And if prime number is not prime number, it is also displaying the factors. And this statement is doing that magic of printing the factors. So first it is verifying is it divisible by 2. If not 2, then 3, then 4, then 5. For example, 5. This 15 will be divisible by not by 2 but by 3. 3 5 is 15, right? So it will continue like this. And this is else part will be executed. So if this is never true, if this never divisible by any number from 2 to that number, then else part is executed, which essentially means it is a prime number. Python nested loop, loop within loop. Python programming language allow to use one loop inside another. That's what we have done. Following section shows few examples to illustrate the concept. We have done that for iterating variable in sequence, then inside another for loop. That's what precisely we have done. While also can have similar nested while expression, another while expression, and continue like that. There is no limitation that how many nested loops you can have. Example of Python nested loop. We are actually trying all the numbers which are prime numbers between 1 to 100. And it's checking all the numbers whether they are prime or not. I equal to 2. So from 2 to 100, j equal to 2, and we are comparing the same while j less than equal to I divided by 2. And this is the precise I was talking about. You can fine tune it. You can take it half of a number. And we are checking. If not, if remainder is not true, then break it. Else increase it. Go to the next number. So execute it. If this cross the half of the number, half of the mark, then it is a prime. And this is 2 is prime, 3 is prime. This is the output you will get in this program. So it is checking all the prime numbers between 2 to 100. This is the nested loop. Very good example of nested loop. One while loop to count the number 100. Second loop to count from 2 to half of the number, so that we can check the divisibility by any number from 2 to half of that number. Assume that at any point in time we have the value 30. So we are counting from 2 to 15 because we are using I divided by j. So I is 30, 30 divided by 2, this is 15. So we are counting 2 to 15. This loop will go from 2 to 15. And we are checking the remainder here. If wherever the remainder is 0, we are breaking it. Loop control statement, break statement, continue statement, pass statement. These three statements break the control, break the flow of the loop. Any change execution from its normal sequence, when the execution leaves a scope, all automatic objects that were located in that scope are destroyed. Python supports the following control statements. Break statement will terminate the loop statement and transfer execution to the statement immediately following the loop. Continue will causes the loop to skip the remainder of its body and immediately retest its condition prior to reiterating. Pass statement is used when the statement is required syntactically, but you do not want any command or code to execute. Means you don't want to do anything. So break statement, which was used in the previous example, it terminates the current loop and resume the execution at the next statement, just like the traditional break statement in C language. So conditional code, if the condition is true, in the condition code you put break anywhere. The break will take you out of the loop. It will ignore the condition. It will break means red flag. You are showing the flag. Come out of it. I don't want to continue. We are interrupting. The most common use of break is when some external condition is triggered, requiring a hasty exit from the loop. The break statement can be used in both while and for loops. If you are using nested loop, the break statement has stopped the execution of the innermost loop and start executing the next line of the code after the block. And the syntax is quite simple, break, nothing else. This is example of break statement. We have done that for letters in Python. If letter is H, break. That means this will be executed, this will be executed, this will be executed, but here this will stop. Though we are saying please continue to all the letters, but here it will stop because we are using break statement. So P, Y, T and then stopped. This statement will never be executed for H. It will be executed only for P, Y and T. Therefore only 3 statements are executed. So this is interrupting the loop, otherwise the loop would have continued up to N, but we are interrupting it at H. Similarly, where 10 less than greater than 0, we are continuing it. Current variable value is this. We are subtracting the variable, so 10, 9. Here it giving you the impression. Similarly here also, this loop will continue up to 10, but then we are continuing if 5. So this is unconditional break. If it is 5, then break. So that means 10, 9, 8, 7, 6. At 5 it will break. Python continue statement. It returns the control to the beginning of the while loop. Means continue will again continue the condition, continue with the condition wherever the condition is given. So it will not exit. It will continue next. So actually it will skip rest of the code. The continue statement reject all the remaining statements. That's what. It will skip rest of the code. Reject all the remaining statement in the current iteration and move the control back to the top of the loop. This is something while skipping some values, skipping some numbers. We use this and continue. Examples of Python continue statement. This is a good example of continue statement in Python. Letters in Python. From H we are skipping it. We are continuing. What does it mean? For P, do. Y, T, yes. For H, continue. Continue means don't continue the loop, but continue from the beginning. That means this statement will not be executed for H, but O and N it will be executed. So that means only H will be skipped. So you will get P, Y, T, O, N. H is skipped. because we use continue statement. Similarly here also, if var is equal to 5, continue. So it will accept 5, it will print all the numbers. 8, 9, 7, 5, 8, 9, 8, 7, 6, 5 missed. So continue will skip or reject the rest of the statements in the loop and will put the loop back. Put the loop execution, the control to the beginning of the loop again. Yeah, pass statement. It is used when a statement is required syntactically, but you do not want to do anything. So it is of no use for that matter. A statement is a null operation actually. Nothing happens when it executes. The pass is also useful in places where the code is eventually go, but has not been written yet. For example, stubs. So it will pass. It will not do anything actually. Actually what you are doing is you are waiting for something to happen. And when you say pass, this block will be executed. This is the pass block. Okay. And this is a pass statement in Python. Then we have generators. That is yield. This is a very interesting feature. We need to learn more about generators. Generators simplifies creation of iterations. A generator is a function that produces a sequence of results instead of a given value. We'll study more about generator in functions because we have not discussed functions in detail yet. We studied but not very well. Like def y range n, I equal to 0 while I less than n yield I. So what is the meaning of this yield? What exactly will happen? And I plus equal to 1. Each time the yield statement is executed, that is yield I is executed, the function generate a new value, means generate a new value of I. So generator is also iterator. You don't have to worry about the iterator protocol, means the incrementing the value, decrementing the value. We don't need that. So the word generator is confusingly used to mean both the function that generates and what it generates. Alright, that's all for this session. I'm sure you enjoyed the session. Thank you.